Hello everyone, I am Angel, and today I would like to talk to you about the phase 2 of our project on adulteration detection and fingerprinting of Philippine honey using stable isotope analysis. But first, what is honey? According to our Philippine national standard, honey is defined as the natural sweet substance produced by bees from the nectar or secretions of plants. Now, honey sold as such shall not have added to it any food ingredients such as sugar syrup. However, one big problem is that honey is a subject for adulteration and fraud. This is commonly done by adding or completely substituting honey for inexpensive sugar syrups coming from what we call C4 plants such as sugarcane or corn. Now, this is being done by perpetrators to lower their production costs and increase their profit. Unfortunately, in the phase 1 of our project, we found out that about 80% of the local honeys being sold in our markets are adulterated or completely substituted with sugar syrup. We were able to tell this using the stable isotope of carbon, particularly carbon-13. Now, in nature, the signature of carbon-13 of authentic honey and the common adulterants such as sugar cane and corn are completely different from each other, as we can see from this plot. Now, in the phase 2 of our project, we plan to expand our analysis, not just focusing on carbon, but now also looking at the stable isotopes of sulfur, nitrogen, hydrogen, and oxygen, as well as the multi-elemental components in honey, not just to be able if it is adulterated or not, but also to establish their fingerprints. More specifically, the objectives and target outputs of phase 2 of this project can be divided into these 5 major activities. Our first objective is to develop more methods. This time we are focusing on a portable or a handheld method for detecting honey adulteration and fraud. We particularly will be using a handheld XRF for elemental analysis, which we can bring to the field or to the market to quickly screen which honeys are adulterated and which ones are authentic. The second objective moves past authenticity and goes into the fingerprinting aspect. Particularly, we would like to be able to tell what species of bees actually made the honey just by analyzing its stable isotope and elemental contents. Not just bee species, we also want to establish fingerprints about the honey's geographical origin. We want to be able to tell which region or even which farm did the honey came from or where it was produced, just again by analyzing its stable isotope and multi-elemental content. Our third objective is to continue and expand our market survey to determine the prevailing levels of adulteration and fraud of honey in our local markets today. So we plan to get samples both from actual physical stores and of course from our online shops. Our fourth objective is to establish a framework of collaboration for actually tackling and battling this problem of honey adulteration and fraud. With the help of the Department of Agriculture and all the other stakeholders involved, we plan to integrate isotope-based standards into our Philippine national standards and into our regulatory system for a longer lasting solution to this problem. The fifth and last objective of this project is the feasibility study and detailed designing of what we call the National Isotopes Center. Now, we envision this to be as a state-of-the-art laboratory and a central facility for food authenticity testing and traceability analysis in the Philippines. We envision this project will have a great positive impact to our local honey industry. Imagine the current situation is that 80% of the local market is dominated by fake honey. What's worse is that this adulterated or fake honey is being sold at 1/3 or 1/4 of the price of the supposed authentic honey. So this problem is forcing our local honest beekeepers to pull down their prices just to survive and to compete. So imagine if we could eliminate the problem of adulteration and fraud, the income of our local honey industry can increase by 10 times or tenfold. For example, if it's currently 25 million, then it can increase by about 200 million or even 300 million. Lastly, I want to point out that this project is part of a bigger program, what we call Food Authenticity and Traceability, or FAT program, which includes other commodities that we can authenticate or trace. So that's it. Thank you very much for your attention.